Hello everyone, welcome to another AMC 8 video. Today we'll go through the 2022 exam of AMC 8. In this video, I'll walk you through all the problems, breaking them down step by step and teaching you all the things that you need to know. I'll also share my best tips and strategies to solve the problems fast and get them done efficiently. So if you're new here, consider subscribing and let's get right into the video.
So in this problem, they want us to find the area of this gray logo, and they have told us that this grid is made up of 1 by 1 inch boxes. So one box has an area of 1. So if we just count the number of boxes that make up this logo, we'll be done. So you see we have 1, 2, 3, 4 full boxes. And then how many half boxes do we have? Because two of them will combine to make a full box. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 half boxes means 6 full boxes. So 4 plus 6 is 10. So our answer should be A. So in this problem, they want us to evaluate this expression right here, which has these two new operations. So let's see what that is. So we have bracket 5 diamond 3 star 6. So first of all, we have to do whatever is inside the parentheses because we still have to follow the order of operations. So 5 diamond 3. So what is the diamond operation? The diamond operation is we square the first number and then minus the square of the second number. So that's what we're going to do. So 5 diamond 3 is going to be 5 squared minus 3 squared, which is going to be 25 minus 9, which is 16. So this expression is just going to become 16 star 6. Now what is the star operation? We take the first number, subtract the second number from it, and then we square the answer. So 16 minus 6 is 10. So 10 squared is 100. So the answer is D. Okay, so in this problem, they want us to find all the possible ways we can choose three numbers, A, B, C, such that their product is 100. And they have to be ordered, so A is less than B is less than C. So that has to be true. So the way you should approach this problem is do the prime factorization of 100. So 100 is 10 times 10, and a 10 is 2 times 5. So I'm using the tree tree diagram method to find the prime factorization of 100. And it's actually very easy because you just keep breaking it down until the ends of each of the branches is a prime number. So we know 100 is made up of 2 2s and 2 5s. Okay, so since all the numbers are made up of prime factors, therefore A, B, C, since they multiply to make 100, must be made up of these prime factors. Okay, but there is one possibility that if one of them doesn't have any of these prime factors, it can still be 1. So let's start with that possibility that A is 1. So that since A is the smallest one, so therefore we can take it to be 1. But then B and C have to be greater than 1. So if A is 1, then let's systematically count our way up. So we are again going to use systematic counting because systematic counting helps us avoid undercounting and avoid overcounting. So we're going to start with the smallest value possible for each of these, and then we're going to work our way up until there are no more possibilities left. So if A is 1, then what is the smallest value B can take? B can take 2. So now 2 is taken, then once A and B are fixed, then whatever is left behind has to be C. So then C in this case would be 50. That's one scenario. It satisfies all the conditions. Okay. Then if A is 1, what is the next highest value B can take? B can be 4, right? Then what is left behind is 25. So that's another possibility. Okay. Then if A is 1 and B, the next highest it can be is 5. If A is 1, B is 5, then what is left behind is 2 2s and a 5. So that would be 20. So that's another possibility. Now, what is the next highest B can be? Well, B can be 10, but then 2 and a 5 are left, so C has to be 10 as well. But that's invalid because C has to be strictly greater than B. So that's not a valid answer. That's not a valid option. So we will ignore that. So now we have run out of the choices we have when A is 1. So let's take the next highest value A can take, and that would be 2. So when A is 2, then B has to be greater than 2. B cannot be 2 anymore, so B has to be 5, right? And when A is 2, B is 5, then what is left behind is 2 and a 5, so that's going to be a 10. So that's another valid option. Now, you can still keep going and try to find other options, but that's completely unnecessary because in the answer choices, the highest number is 4. The highest number of choices we're given is 4. And since we have already have 4 valid examples that satisfy the condition, that means we got the right answer. There is nothing bigger than that, so we don't have to keep going. The answer is E. Okay, so to solve this problem, you have to understand how reflection is done. So how, if you're reflecting anything, any object over a line, how do you actually go about it? So let's say that this is the line of reflection that we have, okay? And we have this arrow that we want to reflect, okay? So how reflection works is that you take a point if that you want to reflect. So let's say we want to reflect this point right here. And from that point, you drop a perpendicular onto the line of reflection, okay? And then you go the same distance the other way. So that is, if this was A, this is where its image is going to be, its reflection is going to be, that's going to be A dash. And you do that for all the points and you get the, reflection of that object. So let's say, let's say this point is B. So the reflection of that is going to be, we drop a perpendicular onto the line of reflection. We go the same distance the other way. So that is where B dash is going to be. So the arrow after reflection is going to look like this. Right? So that's the reflection of that orange arrow in this line. Okay, so we are going to use the same principle because the principle of reflection stays the same in any scenario. So let's do that in this problem. So we have a letter M, which is first reflected over the line Q. The line Q is this. This is line Q. So what would it look like after we reflect it over this line? So you see, this point that is close to it is going to be here, and this one right here is going to be here, right? So since it's the same distance the other way, and then this, so that means this line, this pink line gets reflected into this blue line. And then from there, I can just trace the rest of the letter, right? Like this. Okay, so does it make sense that the letter M reflected over the line looks like this? Okay, now we have to reflect it over line P, which is very easy. Over the line P, its mirror image is going to be something like this, right? Again, this line, this point right here reflects into this point right here reflects into this point, and then the farther points go even farther. So the answer should be E. Okay, so we have a word problem right here, and the way we should approach word problems to save time and to do them in the most efficient way and not to get overwhelmed is that we should read, as we're reading each sentence or each part of the sentence, whatever useful information we get out of it, we should write it down like as a diagram or as an expression, whatever we can. So the goal is to read it once. And as we are reading it, we write down whatever useful information we get out of it. Because the usual approach that students take is that just go through the whole word problem, and most of the times it doesn't make any sense, so they get confused and overwhelmed with all this information, and then they go back and read again. Or even if they understand the problem, they have to go back to read it again because they didn't get the information out. So what we're going to do is, and this is going to work for every single word problem, okay? You go sentence by sentence and you write down whatever useful information you get out of it, and then you just, this way, by the time you get to the end of the problem, you would have all the things you need and you would be able to solve the problem and get the answer. So let's apply that method onto this problem. Let's see if it works. Okay, so they're telling us that Anna and Bella are celebrating their birthdays together. So the day is the same. We don't know if the year is the same, but yeah. So for these kind of birthday problems, it really helps to draw a number line, and that is going to make this problem super easy. Let's see what happens. So let's say this is today, okay, and they're celebrating their birthday on the same day every year. So 5 years ago, let's go 5 years back. So 1, 2, 3, 4, 5. This is 5 years back. Okay, so 5 years ago Bella turned 6. So Bella is 6 years old 5 years ago. Okay, this is 5 years ago. And she received a newborn kitten. So the kitten at this time is 0 years old, right? So they're saying today the sum of their ages, the sum of the ages of the two kids and the kitten is 30. So let's take a look. How old is Bella right now? So Bella was 6 5 years ago. So 7, 8, 9, 10, 11. So Bella is 11 right now. How old is the kitten? The kitten was 0 5 years ago. So 1, 2, 3, 4, 5. Kitten is 5. And Anna, let's say Anna is 8 years old right now. So when you add them up, you should get 30. So we get 16 plus A equals 30. So that tells us that A is 14. So Anna is 14 years old. How old is Bella? Bella is 11. So how much older is Anna? Anna is 3 years older, and that's the answer. Okay, so in this problem, they're saying there are three positive integers equally spaced on a number line. So we draw a number line. They are equally spaced. That means these distances are this distance and this distance is equal. And the middle number is 15, so that's good. That means if this distance is x, like we can say this is 15 plus x, and this is 15 minus x, right? If these two distances are the same. Now they're saying the largest number is 4 times the smallest number. So now we can just apply that condition. So the largest number, which is 15 plus x, is 4 times the smaller number, which is 15 minus x. And we can easily use that to find what x is. So we get 15 plus x equals 60 minus 4x. We move the x's to the left side. We get 5x equals 45. So x equals 9. By the way, x is, what is x? The distance between the numbers. So if this is 15 and x is 9, that means the smallest number is 15 minus 9, which is 6. So the answer is C. We have another word problem here. So they're saying the World Wide Web became popular in 1990s, useless information. So the download speeds reached a maximum of about 56 kilobytes per second. That's important. So speed is 56 kilobytes per second. And then they're asking us how many minutes. So the minutes, that's what they're asking for, would take. So they're asking for time. The time it would take in minutes to download 4.2 megabyte song. So 4.2 megabyte song, that's what we need to find out how long it would take. And they gave us the conversion rate as well. They told us that 1 megabyte is equal to 8,000 kilobits. So what would be the first thing we do? First of all, we need to understand the relation between these quantities. We know that speed is equal to the amount of data, right, divided by the time it takes, right? So if you want to find the time, time would be equal to the amount of data divided by the speed. So if you want to find the time, you have to take the total amount of data you need to download and divide that by the speed of download. So let's see. But for that, they have to be in the same units. This is really important that to use this formula, everything has to be consistent. So we need to convert this 4.2 into kilobytes. So how do we do that? So we have 4.2 megabytes, and I'm going to use a unit conversion trick that is very useful and very easy to apply. So what you do is the unit you want to cancel, you write that opposite to the unit, and then the unit you want to replace it with, you write it in the same place as that unit. And then you balance this fraction using the unit conversion factor that they've given you. So they've told us 1 megabyte is equal to 8,000 kilobits. So that's what it is. So now megabyte will cancel out with megabyte, and the answer would be in kilobytes. And what is it? It's 4.2 times 8,000. Now, this may seem like an overkill. I mean, you could have just multiplied by 8,000 directly, but the purpose is to show you the unit conversion method. And this becomes really useful when the conversions are very complicated or there are like a lot of conversions happening at the same time. So anyways, this will be 4.2 times 8,000 kilobits, and then we divide that by 56 kilobits per second, and the answer will be in seconds. Okay, so to do this calculation, what we can do is, first of all, let's get rid of this decimal point. For that, we can just multiply by 10 on both the top and the bottom. So this becomes 560, and this decimal point goes away. Now, let's try to cancel some common factors before we actually multiply them out. So let's see, we have 8 times 1,000 and 8 times 7 is 56, so 8 times 70 would be 560, and then we can cancel 42 and 70 as well, so 7 times 10 and 7 times 6, and then 10 and 1,000 can cancel as well, so 10 times 1 and 10 times 100. So what do we get? We get 600 seconds as the answer, but they want the answer in minutes. So again, let's do the unit conversion. We put the seconds at the bottom because that's what we want to cancel, and we put minutes here. How many minutes is how many seconds? Well, 1 minute is 60 seconds. The seconds cancel out, and then the answer will be in minutes. That would be 600 divided by 60, which is 10 minutes. Again, of course, that's very obvious that 600 seconds is 10 minutes, but I just wanted to again show you the unit conversion method that we are trying to learn. So the answer is going to be B. So in this problem, they want us to evaluate this expression, but don't just go and start multiplying them out, because there is a much more efficient way. Whenever you have fractions being multiplied, the very first thing you should check is if there are any common factors between the numerators and denominators that you can cancel out, and that will make the multiplication, very simple. And we can actually see there are a lot of cancellations that will happen here. So let's write them down. So we have, in the numerators, we have 1, 2, 3, 4, 5, and it keeps going like that. 16, 17, 18, 19, 20. I'm going to write a bunch of them. And then the denominators are just two more than the numerators. So it's 3, 4, 5, 6, 7, and then 18, 19, 20, 21, and 22. So we see that 3, 4, 5, 6, 7, all of these are going to cancel out with the numbers here, because 3 until 20 is going to come in the denominators as well. So all of these are going to cancel out with these at the bottom, right? So 3 to 20 at the top is going to cancel out from 3 to 20 at the bottom. But the numbers that will not cancel out are going to be 1 and 2, because there is no 1 and 2 in the denominator. And then also 21 and 22 in the denominator, because there is no 21, 22 in the numerator. The numerator only goes until 20. So after all the cancellation, we are left with 2 over 21 times 22. Now again, before you multiply it out, check if there is any cancellation we can do here. Are there any common factors we have? And we do have a common factor of 2 here. So the answer would be 1 over 11 times 21. Now, what would that be? An easy way to do that would be 21 times 10, which is 210, plus another factor of 21, which is going to be 1, 3, and 2. So 231. 1 over 231 is going to be the answer. So the answer is B. Okay, so in this word problem, they told us that a cup of boiling water has a temperature of 212 Fahrenheit. Okay, and the room temperature, which stays constant, it doesn't change, is 68 Fahrenheit. Now their difference is halved every 5 minutes, and they want us to know what is going to be the temperature of water after 15 minutes. What is their difference right now? Okay, so 68 to 100 is going to be 32, and then 112 all on top of 32 is going to be 144. So their difference right now is 144. After 5 minutes, this is now, after 5 minutes, it's going to halve, so it's going to become 72. And after 10 minutes, it's going to half again. It's going to become half of 72 is 36. And after 5 more minutes, it's going to halve and become 18. So since the room temperature stays constant, it's still 68. And then what is the temperature of water? It's 60 is 18 more than 68. So 68 plus 18 is gonna be 6, 7, 8, 86. So that's the temperature of water right now. The answer is B. Okay, so this is a very simple graph problem. Let's see how to approach this. So we will again go through it one sentence at a time and try to see what the diagram should look like. So they're saying that Ling decided to take a hike. Okay, she left the house at 8 a.m. So 8 a.m. is when the journey starts. So it should be like this is 8. Then she drove at a constant speed of 45 miles per hour and then reached her destination at 10. So after 2 hours. So if you drive for 2 hours at 45 miles per hour, you would cover 90 miles, right? So that is the point that she should be at the 10 a.m. mark. Then she hiked for 3 hours. That means during that time she did not move at all. So those 3 hours she's gonna be at the same level. And then after that she drove back home at a speed of 60 miles per hour. Now the distance from that place to her home is 90 miles. We know that from from the initial journey. So if she drives at 60 miles per hour, it's going to take her 1.5 hours. So 13, 14, and 14 and a half. That is where she should um, yeah, this graph should touch down. So let's see which of these graphs is closest to this one. So we start at 8, go to 90. So this is off, this is off, this is off. So we only have these two choices. Let's see. In A we go till 90 and then we stay there for 3 hours and then we come back in 2 hours. That's wrong because we know we come back in 1.5 hours, and that is represented accurately in answer choice E, so that's the right answer. Okay, in this problem, Henry the donkey has a very long piece of pasta. At the beginning, it's going to be one single piece, and he takes a number of bites from the pasta, and each time he eats 3 inches from the middle of one piece. So eating from the middle will break it down into, so if you have a piece of pasta, you eat from the middle, it's going to break it down to 2 pieces, right? So um, at the end, he has 10 pieces whose total length is 17. So we want to find out how long was the initial piece of pasta. So what the question is, we're going to define that as our variable. Okay, so let's say at the beginning, and we're going to run by the scenarios and see if we can find a pattern. So at the beginning, we had x, and so we're going to make two columns. Let's say one is going to be the number of pieces, okay, and the other one is going to be the total length. Okay, so at the beginning we have one piece which is x long, right? And then then Henry eats from the middle 3 inches, right? So the length decreases by 3, and the number of pieces are now 2. They increase by 1, right? And then we have two pieces. It doesn't matter which piece Henry now eats from or bites from. The number of pieces are again going to increase by 1, and the total length is going to decrease by 3 again. If at the end he has 10 pieces, that means how many bites he took? He took 9 bites, right? This is plus 9. That means we decrease x by 3 times 9, right? Because every time you take a bite, it decreases by 3. So now we know that the length right now is x minus 27, which is equal to, which we know is 17. So x must be 17 plus 27. So what is that? 17, 27, 4, 1, 2, 3, and 4. 44. So the current length or the initial length was 44. So the answer is D. So this right here is a probability question. And whenever you have a probability question, there is only one formula we need to know, and that is probability is equal to number of favorable outcomes divide by number of total outcomes. So that's what we need to figure out. What are the total number of possibilities and how many of them are favorable? That's how you solve probability questions or find the probability of any event. So here in this particular scenario, we have two spinners, and they're saying n is a number that is equal to 10 times the number on spinner A plus the number on spinner B. And they're saying what is the probability that it will be a perfect square. Now, first off, let's find the total number of possibilities we can have. Now, there are four possible numbers we can get out of A, four possible choices for A, and there are four possible choices for B. So the total number of choices in this, since they are independent events, whenever you have two independent events, to find the total number of possibilities, we can multiply them together. So the total number of choices we have are 16. Okay, that's the total. Now, how many of them are favorable? One really simple thing we can do is actually check each of these scenarios, because there are only 16 possibilities. The fastest way would be to just quickly check them out. Okay, so we'll brute force this problem. If it was like a really big problem, like 100 possibilities, then of course we will have to try and find some smarter way. But here, it's completely unnecessary. So let's see. If A is 5, let's see if we can do this. And this is going to be easier than it looks. So if A is 5, we get n equals 50. So that's A equals 5. 50 plus B. Now, is there an option here that will make it a perfect square? What are the perfect squares? Let's write them down on this side so that we can quickly check them out. The perfect squares we have are, let's say, 36, 49, then 7 squared. 8 squared is 64, 9 squared is 81, and 100. So this should be enough, right? So greater than 50, there is only one square, like closest square is 64, and we don't have any number like that. So there is no possibility, no possible perfect square we can make with A equals 5. Then let's move on to A equals 6. Then n would be equal to 60 plus B. Now there's only one possibility because B is just 1, 2, 3, 4, and that is 64. So A6 and B4, that's one possibility. Now, what about A equals 7? Well, no possibility there, because the closest one is 81, which is too far. And then A equals 8, that will be 80 plus B, and that means B must be 1. So 8 and 1, that's another possibility. And then that's it. We ran through all the options, and we find out there are only two possible favorable outcomes. So the answer would be, the probability would be 2 over 16, that is 1 over 8. So the answer is B. Okay, so in this problem, they want us to find out all possible positive integers that can fill in this blank. Right, so let's call that x, because that's what we want to find out. So let's see what it's telling us. They're saying one positive integer is x more than twice another. So if one number is p, the other one is going to be 2p plus x twice, and then x more. And then we know that these two integers add up to give us 28. That means 3p plus x equals 28. That means 3p is equal to 28 minus x. Now, since we know that p is an integer, that means 28 minus x must be a multiple of 3, because if this is not a multiple of 3, then p would not be an integer. The biggest one would be 27, which we get when x is 1, and the smallest we can make is gonna be 3, which we will get when x is gonna be 25, right? And it can't be like, we cannot make it to be anything less than 3, because then p is not going to be a positive integer. So how many values of x we will have? Well, from the first multiple of 3 to the ninth multiple, this is 3 times 1, this is 3 times 9, and all the ones in the middle, all the multiples in the middle will also have their corresponding x. So there will be 9 values in total that we can have for x that will still satisfy this condition. So the answer is D. Okay, so this is a very simple counting problem if you know the trick. So what we have to do here is we have to find the number of ways we can rearrange the letters in this word beekeeper, um, so that two or more e's do not appear together. So e's should not be together. Okay, so let's see, how many e's do we have? 1, 2, 3, 4, 5. So we have 5 e's. 1, 2, 3, 4, 5. Now, to make sure that these two e's do not appear together, we have to have a letter in between them, right? And we have to have a letter here, here, and here as well. right? If we don't have a letter in any of these places, the e's will be together, and then we will not, satisfy the condition. So these e's, of course, they are all the same. So let's fix them. And what we are gonna do is we're gonna just find out how many ways we can, put the letters that separate them. So we have, what letters do we have? We have B, K, P, and R. They're all different letters. B, K, P, and R. So for the first one, we have how many choices? We have four choices for the first one. Then once that is chosen, we have three letters left. So we have three choices for the second one, two choices for the third one, and only one choice for the last one. And since they're all then independent, we can multiply them out. So we have a total of 4 times 3 times 2. That's 24 ways to choose, how to put the letters in between the e's. And since that's the only possible way to separate the e's, therefore there are no other possibilities. And the answer is going to be 24. That's D. Okay, so in this problem, this person goes online and finds 30 different options for black pepper, and they all have different price and weight. And each of these black dots represent each option, and we have the price on the y-axis and we have the weight on the x-axis. And what do they want? They want the weight of the pepper that has the lowest price per ounce. What is price per ounce? So price is the y coordinate over the weight, which is the x coordinate. Now, y over x, that's actually the slope from the origin, right? That is the slope from the origin. So we are trying to find which point makes the smallest slope with the origin. So for example, between these 2 points, of course, we can clearly see it's going to be this one. But we can just visually see which point is going to do that. And that's going to be really easy to check. For example, we can just draw these and we find out, okay, I think that this is it. Yeah, this is gonna be the one that makes the smallest slope, because there is no point under this line, so it has to be this one. And what is the weight of that pepper option? It's 3, so the answer is C. Okay, they've told us that four numbers are written in a row. Let's call them W, X, Y, and Z. The average of the first two numbers is 21. What does that tell us? Let's just write it out. That means W plus X divided by 2 is 21. So W plus X is 42. Okay, that's what we know. Then the average of the middle two is 26. In the same way, we will find out that X plus Y is equal to 2 times 26, which is going to be 52. Okay, and then the average of the last two is 30. That means y plus z is gonna be 60, right? Y plus z divided by 2 is 30, so y plus z is 60. Okay, now how do we find the average of the first and the last numbers? What would that actually be? That would be w plus z divided by 2. But we need to find w plus z first. Actually, there is a really easy way to find w plus z directly if you take w plus x, subtract the second one, x plus y, and then add y plus z. What do you get? So you get w plus x minus x plus y, and then plus y plus z. Does that give us our desired answer? So we get w plus x minus y plus y and plus z. The x's cancel out, the y's cancel out, and we get w plus z. So that if we just do that operation, we will get w plus z. And what would that be equal to? W plus x is 42 minus y plus x plus y is 52, and then plus 60. And since we have to follow the order of operations, we go from left to right. So 42 minus 52 is negative 10. Negative 10 plus 60 is going to be 50, and w plus z is 50. Therefore, w plus z divided by 2 is going to be 25. So the answer is B. Okay, so in this problem, they're defining this notation n double factorial as the product of all the even numbers from 2 to n. For instance, 8 double factorial is 2 times 4 times 6 times 8, and so on. And what they want is they want us to find the units digit, which is the last digit of this whole sum. Now, this may look very scary, but actually it's very simple, because since we want to find the last digit of this whole sum, we only need to know the last digit of each of these individual numbers, and then we will be able to find the last digit of this whole sum. Now, it's very interesting if you just write it out. So 2 double factorial plus 4 double factorial plus 6 double factorial plus 8 double factorial plus 10 double factorial. Now, 10 double factorial onwards all the way up till 2022 double factorial, all will have a multiple of 10 inside of them, which will make the last digit to be 0. So the last digit of each of these numbers is going to be 0, so we can just ignore them. Now we just need to figure out what the last digit of this sum is. So let's find that out. So this is 2 times 4, 2 times 4 times 6, 2 times 4 times 6 times 8. So this is just 2. 2 times 4 is just 8. 2 times 4 times 6. So 2 times 4 is 8 times 6 is 48. So the last digit is 8. And then here, 48 times 8, well, 64, 32, and 6. So 384. So the last digit is 4. So now we add them up. We get 22, which has a last digit of 2. So the answer is going to be B. Okay, this is a really simple coordinate geometry problem. In this problem, they have given us the 4 midpoints of a rectangle, and they want us to find the area. So let's plot these coordinates on a coordinate grid to see what it looks like. So we have negative 3, 0, so 1, 2, 3, that's negative 3, 0. Then we have 2, 0, so that is 2, 0. Then 1, 2, 3, 4, 5, 1, 2, 3, 4, that's 5, 4. And then this is 0, 4. Okay, so these are the 4 midpoints that we have. Okay, now let's look at a rectangle and see if we can observe something about the midpoints. So if you have the midpoints and the opposite midpoints, if you join them with a straight line, they're perpendicular to each other. So that means these are those two lines that go through the rectangle and they're perpendicular to each other. And what we observe is that the length of the rectangle is the same, is equal to the longer line between the midpoints. So this is gonna be our length. Okay, this is our length, and the width is going to be the distance between the other two midpoints. So essentially what is going to happen is if we find the distances between those midpoints and multiply them together, that's going to give us the area, because the red line is just the length and the pink line is just the width. So let's quickly find the distance between those points. So how do we find the distance between 2 points? It's essentially using the distance formula, which is just Pythagorean theorem. So if you want to find out this red distance, you can think of it this red triangle right here. And here, what is this length? This length is 1, 2, 3, 4, 5, 6, 7, 8. So that's that red triangle. Let me draw that here. This length is 8. What about this length? This is 1, 2, 3, 4. So we use Pythagorean theorem and we find out that this length must be 8 squared plus 4 squared square root, which is going to be 64 plus 16 square root. That's square root of 80. You can use the distance formula, but it's essentially the same thing. And the right triangle, using the right triangle is actually easier to think about. So now let's find the distance between these two midpoints. So again, let's just use this blue right angle triangle. We see that this blue right angle triangle has a base of 2 and a height of 4. So the hypotenuse is going to be 2 squared plus 4 squared square root. I've just used the Pythagorean theorem. So it's going to be square root of 4 plus 16, which is square root of 20. So now this is the length and this is the width. The area of a rectangle is length times width, which is going to be square root of 80 times square root of 20. Now, there is a property of square roots that you can multiply the insides, okay? And this is going to be essentially equal to 80 times 20, square root of 80 times 20, which is square root of 1600. And 1600 is just the square of 40. So the square root of 1600 is going to be 40. So the answer is C. Okay, so in this problem, we have the test scores of 20 students, and it's shown here in the dot plot. And they're saying that the teacher awards 5 extra points to some of the students. and that increases the median to 85. Now, what is the median? Median is the middle value. But when you have even number of terms, the middle value is the average of the middle two terms. Now, since we have 20 students, it's going to be the average of the 10th and the 11th student. Now, for the average to be 85, they both have to be 85 themselves. Okay, so this must be 85 and that must be 85. That means there must be 9 students on this side and 9 students on this side. Now, what is the current scenario? We have these students at 85. How many are less than 85? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 students less than 85. And then we have 1, 2, 3, 4, 5 students greater than 85. So to make them 9 and 9, we need to move 4 students from here to this side. Okay, and we can do that by adding 5 to, let's say, these 4 students. So we have one student at 80, and then these 4 students just become, come here at 85. We can consider them to be here, let's say, like on this side of the 85 students. So um, we would have, after we move those 9 students until 80, and then we will have two 85s, and the rest of them, they can be 85 and above, are going to be on this side, which will be again 9 of them. So that will make it so that the 10th and 11th student have the score of 85. So the answer would be 4, and that is answer choice C. Okay, so in this problem, they want us to fill this grid with numbers, and the condition they've given us is that the sum of each row and each column is the same. And what is it? It is actually 9 plus 5 is 14, minus 2 is 12. And then, yeah, 8 plus 5 is 13, minus 1 is 12. So that is true. Like these all have to be 12. Now, the easiest way to approach this problem would be to plug in the answer choices, because they have given us the condition that the lower left number is larger than the other three. So we plug in, find the other three. If it's larger, then it is gonna be the right answer. Now they said, what is the smallest possible value of x? So we start plugging in answers from the smallest, upwards, because as soon as we get an answer, we can just put that in and move on. But if you start checking from the left side, from the right side, from the biggest number, then even if, for example, 9 works, we don't know if it's the smallest or not. Maybe 6 works as well. So therefore, the right approach to this problem is to plug in the answers starting from the smallest one, and as soon as we get an answer that satisfies the conditions, we pick that and move on. Okay, so let's try that. What if it's -1? So if x is -1, then this has to be 8 minus 1 is 7, 7 plus 5 is 12. This has to be 5, but it violates the condition that x is supposed to be larger than the other three. So therefore, 1 is not the answer, -1 is not the answer. Let's plug in 5. And I think the problematic part is going to be this. See, because this is going to give us the smallest sum, and therefore this has to be as big as possible. So yeah, therefore let's do that first. So 5 minus 2 is 3, and 3 plus 9 is 12. So therefore that again violates the condition, so it cannot be 5 as well. Let me remove that. Okay. Then let's try 6. If this is 6, 6 minus 2 is 4. 4 plus 8 is 12. Well, that is also not valid. What if this is 8? So 8 minus 2 is 6, and 6 plus 6 is 12. So that works. Actually, let's see if the others work as well. So 8 plus 8 is 16. 16 minus 4 is 12. And then 6 minus 1 is 5. 5 plus 7 is 12. But we still have to verify if this adds up to 12 as well. So this checks out, this checks out, this checks out, this checks out. But what about this one right here? So 9 plus 7 is 16. 16 minus 4 is 12. So this checks out as well. So the answer is going to be D. Let's approach this word problem step by step. So what are they telling us? They're telling us that Steph scored 15 out of 20 baskets in the first half of the game and 10 out of 10 baskets in the second half. So actually this information right here in the first two lines until here is just this table. So we can see in the first half, Steph scored 15 out of 10. In the second half, he scored 10 out of 10. Candice in the first half scored some amount out of 12 and second half out of 18. Now, this is the important information. In each half, Steph scored a higher percentage than Candice. So we know that Steph's percentage is higher. But at the end, they ended up with the same overall percentage. So if they have the same overall percentage, let's see what is the percentage, overall percentage for Steph. The overall percentage for Steph is 25 out of 30. Candice has right up to 25 uh, as well, and out of 30, because 12 plus 18 is also 30. So these two numbers add up to 25. That's what we know. Now, we also know that this percentage is higher, so 15 out of 20 is how much? It is 75%. And what is 75% of 12, or like 3/4 of 12? That would be 9. So this has to be less than 9. Okay, let's say it is 8. Okay, less than 9 is 8. And then 10 out of 10 is like 100%, so anything less than 18 is gonna work, right? So this can be, let's say, whatever else we are left with. So 25 minus 8 is gonna be 17, right? So that is less than 100%, so it does satisfy the condition. So these are the two numbers. Again, if we decrease this by one more, then this would have to increase by one, and that will make it 100%. So that is actually the limit. This has to be 8 and this has to be 17. So how many more did Candice score in the second half than the first half? That's 17 minus 8, which is gonna be 9. So the answer is C. So this is a very interesting combinatorics problem. So let's walk through it step by step. So they're saying that there is a bus that takes 2 minutes to drive between the stops and waits at each stop for 1 minute. Okay, and then there is this person Zia who walks for 5 minutes and then keeps walking until the bus is at the previous stop or somewhere in between when she reaches a particular stop. So you want to find out where they'll meet. And again, the most straightforward way of doing this would be just to go through the problem. So let's see what happens. After 5 minutes, Zia is here. But let's see where the bus is after 5 minutes. So 2 minutes here, one here, two here. So that's two, 3, 4, 5. At 5, the bus just stopped at this stop, and since it's not the previous stop or somewhere in between, therefore Zia will keep walking. Okay, so Zia will be here at 10 minutes, but where is the bus at 10 minutes? So let's see, 1 here, so 5, 6, 7, 8, 9, and then somewhere in between, that's where it is. Okay, so that is where we'll have the bus will be at 10 minutes. So since again it's not at the previous stop or somewhere in between, the Zia will keep walking and will go to the next stop. She will reach there at 15 minutes. So the bus is here, so that's 10. So this so on the way, again 2 and 1, so 11 and then 12. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At 12 it leaves the stop. 13, 14. At 14 it reaches the stop. Okay, and um, it stops there for 1 minute. So at 15, the bus is about to leave the stop, and at 15, Zia just reached this stop. So since the bus is at the previous stop, Zia will wait here because at 15 the bus is here, right? So therefore Zia will wait, and then the bus will get there in 2 more minutes. So at 17 minutes, bus will be here, and you can check if the bus will be there or not in 17 minutes actually. So 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and at 17 it's here. So they're saying, so And after how many minutes will Zia board the bus? Since Zia is already standing there, as soon as the bus comes, she boards. So the answer will be 17. Okay, so in this problem, we have a 3 by 3 grid in which we can place as many triangles and circles as we want, but the goal is to find out the number of configurations in which we'll have 3 triangles in a straight line and 3 circles in a straight line. So it's like a line of triangles and a line of circles. So this is again a counting problem, so we will again use systematic counting. Okay, so let's observe first of all this, that if the triangles are in a column, then the circles have to be in a column as well. If the triangles are in a row, the circles have to be in a row as well. So let's take the column scenario first. So we have 3 choices to place the column of a triangle. Okay, the column of triangle, we have the column of triangle, we have 3 choices to place that. So let's say we place that here. Then after that, we have 2 choices for the column of circles, right? So we have 2 choices for that, and then that gives us a total of 6 choices for placing the triangle in the circle. Now the last 3 can be anything, but we have to be a bit careful with this, because when this is also a line of circles or a line of triangles, there will be some overcounting. So let's actually keep it simple, and let's assume that the last 3 are not a line of circles or triangles. There are some different line, like 2 triangles in a circle or 2 circles in a triangle, or something like that. So if they could be anything, right, there will be 2 choices for this, 2 for this, 2 for this. So there will be a total of 8 choices for the last column, but we are removing the choice where you have all circles or all triangles, right? So that means we are left with 6 choices. So in total, when we are not considering a full line of circle and a full line of triangle in the last column, we'll have 6 possible configurations. And that means the total number of configurations we will have right now are 3 times 2 times 6, which will be 36. This 3 came from the 3 choices we have for the row of triangles. This 2 came from the 2 choices we have for the row of circles. And this 6 came from the 6 possible configurations we can have in the last column, okay? Which will just be like 2 circles in a triangle and 2 triangles in a circle, okay? 3, 3 each. So that gives us 36. Now let's consider the problematic scenarios in which we have a whole line of circles. So in that case, we'll have a line of triangles and 2 lines of circles, which will have 3 possible ways to order, right? We'll have 3 possible ways to order this. So that would be plus 3. And 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 then if we have the last one is a line of triangles, then we'll have 2 lines of triangles and 1 line of circles. So there will again be 3 ways to arrange these three different configurations we can make out of these. So in total, for the column case, we will have 36 plus 3 plus 3, which is 42 possible configurations. Now, the row case is exactly symmetric to the column case, right? So therefore, we can say that it will be the same amount. So we can multiply that by 2 and we get 84. So the answer is going to be D. Okay, so in this geometry problem, they have given us a net which is folded to make a triangular prism. Now, what is a triangular prism? First of all, we can observe that in this net, there's only one triangle. This is a right angle triangle, like one type of triangle. So what would a triangular prism look like? So a prism is when you take a shape and you stretch it out, okay? So if we have the triangle like this, and we stretch it out in one direction, then this is what the prism is going to look like. So it will have 2 triangles, the bottom and the top, and then these 3 rectangular sides. So they have given us some information. Let's see what that is. By the way, let's use this one right here as the bottom triangle. Okay, and then we're gonna make the shape around it. So they have told us that AH is 8 and EF is 8 as well. And GH, this whole length, is 14. Now, if this right here is the base, so let me actually use a different color. So this is the base, and here this is the base. Then this length goes on like besides this base perpendicularly. So that is gonna be let's say this is I, this is F, and this is C. So the Fi, the side that goes with that, is going to be this one, and it will have a height of 8. So this side right here is going to be this one, and that has a height of 8. That means since the height of all the sides would be the height of the prism would be consistent, so this is going to be 8 for all of them. So this is going to be 8. Okay, and then this side is going to go perpendicularly to this, so that means this length right here, this one, is going to be the one that is perpendicular to C, this one right here. So that is 8 as well. So we know that this is 8, and then this is 8 as well. And then we have this other side triangle that goes on the top, and then this must be 8 as well, because that is going to be the so this side right here, this black one, is actually the one along the hypotenuse. Okay, but this side, this shape is gonna be along along this side right here. So again, the height of this green uh, shape is gonna be 8 as well. So this is also 8, and then means this is also 8. And since three sides are 8, and it is all the angles are 90, therefore this must be 8 as well. Okay, so if this whole side, they told us that GH is 14, and we found out that HJ is 8, that means this side must be 6. So now we know two sides of the base. So the base is 6 by 8, and the height of the prism is also 8. So what is going to be the volume of this prism? The volume of the prism is going to be the base area, which is half 6 times 8, times the height of the prism, which is 8. So it's going to be 6 times 4 times 8, which is 24 times 8. So what is 24 times 8? It's 32, 192. So the answer is going to be C. Okay, so in this problem we have a cricket which is hopping on 2 leaves with equal probability. So from each leaf it can go to any of the other 3 leaves. So they're saying after 4 hops, what is the probability that the cricket has returned to the leaf that it started on? Now to keep track of things, let's label the leaves. Okay, so I'm going to call this 1, 2, 3, and 4. Okay, just to make things easier to keep track of and easier to understand. And secondly, since this is a probability problem, we know that probability is what? Number of favorable outcomes over number of total outcomes. So let's actually count the number of total outcomes that we can have. So we start at 1, so I'm going to do that here. So we start at 1, and then we do 1, 2, 3, 4 hops. So the total counts like every single possibility. So for the second hop we have 3 possibilities. From that we have 3 possibilities for the second hop, and then 3 possibilities for the third hop, and 3 possibilities for the fourth hop. Since there are no restrictions on the total, therefore the total number of possibilities we'll have will be 3 raised to power 4, which is 81. So that's the total number of possibilities we have. Now we have to find the possibilities in which we start and end at 1. So that's going to be interesting. So we have 1, so starting at 1, and then we have first hop, second hop, third hop, and then the last hop has to end at 1 as well. Now this is something really interesting, that if you're starting at 1, you have 3 possibilities for the second hop, right? It can be 2, 3, or 4. Okay, not sure about the middle one, but if you want to end up at 1, then previously you have to be not at 1. So this has 3 possibilities as well, 2, 3, 4. Now the middle one we can actually systematically count. Okay, let's say that the middle one is 1 as well. In that scenario, how many possibilities would we have? So We start at 1, we have 3 possibilities for the second hop, then we go to 1, right? So 3 possibilities for the second hop, then we go to 1, and then we have 3 possibilities for the third hop, and then we go to 1. So 3 times 3, there are a total of 9 possibilities in the case that the middle one is 1. Okay, let's look at the scenario where the middle one is 2. Middle number is 2. Now, uh, on the second hop, on the first hop, it cannot be 2 because it's going to be 2 on the second hop. So there are 2 possibilities only for the first hop, then it's 2, and then from 2 it cannot go to 2, but it also cannot go to 1 because because if it's already at 1 here, then it cannot hop on the last hop to 1. So there are only 2 possibilities here as well. It can either go to 3 or 4. So when the middle number is 2, we have 2 times 2, 4 possibilities. The same thing goes for 3, right? If the middle number is 3, let's actually try that scenario. So 1, 2, 3. So if the middle number is 3, then from 1 we would have to go to either 2 or 4. Then we go to 3, and then from 3 we would have to go to either 2 or 4 again and end up at 1. So again, 2 times 2, so again 4 possibilities. And for 4 it's going to be the same, all right? It's going to be the same. We have to go to either 2 or 3 from the first hop, and then we have to go to 4, and then we have to go to 2 or 3 again because we can't go to 1 or 4. So 2 times 2, again it's gonna be 4 possibilities. So in total, how many possibilities do we have? Well, we add them all up and we get 9 plus 12, which is 21. So we have 21 favorable possibilities. And again, we count it systematically, right? The middle one can be 1, 2, 3, or 4. Since we went through all possible scenarios and counted the number of possibilities for each scenario, therefore, we must have counted all the possible scenarios we have, and therefore, this should be the right answer. So 21 over 81, what is that? So 21 over 81, we can divide them by 3. So it's 3 times 7 and 3 times 27. So the answer must be 7 over 27. So the answer is E.
So guys, that's all for today. If you enjoyed the video, then press the like button and let me know in the comments below what you thought.